Hey everyone, welcome to your Play Posit for the week. We are going to be covering the last part of your notes from last class. So this does still correspond to 2.8. Let me turn my tablet around. 2.8 in your OMHS. So go ahead and grab those notes from last class. Don't forget that next Tuesday we have a special math virtual event for you guys. We're going to have a city senior industrial design manager who actually works in New York come and talk to you about how to design your own products. So hopefully you guys can join us for that on Tuesday at 1:30. That Zoom link will be on your daily plan towards the very bottom, and the passcode as always is VAVA 2020. So here we are. If you might remember this diagram from Tuesday, time permitting, here's our time right now. We're going to get to the whole enchilada now. Oh man, I really want some like Taco Bell right now or Mexican or something. That's why I chose the enchilada. But one of those things encompassed in that enchilada is factoring special cases. So we have a special case called the difference of two squares, and that's what we're going to get to today. But before we do that, I thought it'd be a good idea to review and recap our breakout room assignment that we did last class. So naming this polynomial has three terms, so that makes it a trinomial. That's all we needed to say here. We could ask it like, what is the degree? And the degree of this polynomial is 4, right? That's the highest exponent value of any term. There's only one variable in the first and second. So the degree here is 4, the degree here is 1, and the degree here is 0. So sure enough, 4 is the largest. So that makes the leading coefficient -5. Not because it's in front as a leader, but because it's with the term that has the degree of the entire polynomial. All right, simplify. So when you have a minus in the middle, you just want to remember to distribute it to everything on the inside. So this negative here or minus, it means the same thing. It's going to affect the sign of every single term in here. Going to make it opposite. So I'm just going to rewrite this and then make sure that we change the sign of each of these terms. So this will be a plus 6n to the fourth, plus 3n, and plus 8n to the fifth. Now's the fun part. We're just going to start collecting like terms. So here is an n to the fifth and another n to the fifth. So -6 plus 8 is a positive 2n to the fifth. Then we have an n to the fourth and an n to the fourth. So -8 plus 6 is a -2n to the fourth. Then we have just our n term. I'm going sort of in decreasing order there of those exponents. You don't have to, it's just kind of the way we write it in standard form. There we go. The second example for multiplication. So we have two binomials being multiplied together. Remember, a binomial has two terms, 1, 2. So there's two ways to do this. We can distribute. You may remember my example of going trick-or-treating, right? Or you can use the FOIL method if you saw me do that or if you looked it up. I prefer distribution because it's always going to work. FOIL only works when it's two binomials. So let's distribute. We're going to take the first term and multiply it by everything over here. That term is going to visit both houses. So 3m times 8m plus 3m times 7. Okay, then we're going to do the same thing with that second term. -1 times 8m and -1 times 7. That's really the hardest part. That's the algebra part. I mean, this part is also algebra, but it's something you also learned in pre-algebra, kind of just simplifying, right? So let's go ahead and multiply. 3 times 8 is 24. Well, this part's definitely algebra, right? M times M, when we multiply two variables, you add the exponents. So that becomes m squared. 1 plus 1 is 2. 3 times 7 is 21m. Then you have minus 8m and minus 7. So we're pretty much done, but let's go ahead and combine like terms. And you'll get, what is that? 13. 13m minus 7. So I know we kind of talked about this last class, that this, we call this the factored form. It's like a synonym for this. This is the expanded form. So they mean the same thing. We did not change the value one bit. We just wrote it differently. And we've been doing this a lot more, right? Going from the factored form and multiplying to get to this expanded out form. And again, what we're working towards is to go the other way, where I'm going to give you guys this expanded form, and you're going to be able to write it in factored form. Pretty cool. And writing something in factored form is going to help us solve for that variable. So you'll see all that come to fruition very soon. All right, our last example here, we're going to find the GCF. So I'm going to use the cake method. I see a 3, right? So 3 into 9 goes 3 times. 3 into 12 goes 4. And we're done. When you look at these numbers, we didn't get to a 1 like we have a lot of other times, but 3 is still prime, right? The only factors of 3 are 1 in itself. So unless this number can also be factored by 3, we're finished here. So our GCF is 3, but then what about the variables? So this guy has 1x, and this one has 2. So the most that we could take from both of those is just 1, right? We're trying to find what they have in common. And then the first term has 2y's, and the second has 3. So the largest thing they have in common is 2y's. You could definitely list these out like we've done if that's helpful for you. It doesn't take up much space. It doesn't take much time. And you can kind of visually see them line up. So 1x and 2y's. All right, now we're going to actually factor it out. So we're going to put the GCF on the outside. And let's see what's left over. So I'm going to get a different color real quick. A lot of people like to sort of do this systematically where they'll rewrite the original and then just take it one term at a time. So you're literally taking each term and dividing out that GCF. So 9 divided by 3 is 3. These x's cancel out, and these y's cancel out. And then looking over here, we're going to subtract. 12 divided by 3 is 4. We have x squared over x. So remember, when you have two variables on top of each other dividing, you're going to subtract the exponents. So 2 minus 1. So you'll have 1x left on top and 1y. Again, if you forget that rule, you can do the same sort of idea. You can expand it out, x and 2y's, and then see what divides out. And see, you only have 1x and 1y. Here we go, we're done. These are synonyms, this guy and this guy, and we factored it out. So now, factoring goals. I love this meme so much. So this is you, Captain America. Just kidding. You can be anybody. And here's a polynomial. And look what Captain America is doing. He's splitting the wood with his hands and breaking it apart into those two factors, those two binomials. So that's the whole point of factoring. You're going to start with a trinomial usually, and you are going to write it as the product of two binomials. Product meaning multiplication, right? This is our goal. We are very much used to going from this to this. We can multiply that out, right? We can distribute. But what we're going to work towards is going from this to this form. And it's an entirely different process. So first we're going to start with a special case. And it's called factoring the difference of squares. And the nice thing about it is the name matches the process because difference means subtraction. So you can see every single problem on this screen has a minus in the middle. So that's a big deal. It has to be done with minuses. And in order to do it, you have to be subtracting two squares. So the question would be, can you write each of these terms as something squared? So x squared, that's already written as something squared. I can put it in parentheses to kind of emphasize that. Can you write 25 as something squared? Hopefully you're thinking of 5, right? 5 times 5 is 25. Let's try these two terms. So we need to have the whole term and then squared. This is sort of our model. So how can we write 4 as something squared? And that's 2. And the C. And you can always sort of check it and go backwards. 2c squared means you would write this, right? It means you would write it twice. So 2 times 2 is 4, and c times c is c squared. So sure enough, it is the same thing. Then 49 can be written as 7 squared. And we're going to see on the next slides what to do after this part. I just wanted you guys to have some practice writing the terms as something squared. So remember, at any time you can pause this recording and try them on your own, and then come back for the answers. So they're all going to be something squared minus something squared. So the first one, we're going to have 5y and x. And hopefully it starts to feel really easy. You kind of just see it, right? And you can also use your calculator if you need to. You can take the square root of these things. The square root of 4 is 2, so that's how we know 2 times 2 is 4. We have the y. And then square root of 9 is 3. 3 times 3 is 9. This is fun. Let's keep going. So this just has a d. Of course, there's a 1 there, but 1 is always implied. And 6 times 6 is 36. Something squared minus something squared. We're going to have a minus 5b. There we go. So that's it. That's sort of the first step. Whenever you have a binomial, two terms, the very first thing you should try to do is to set it up as a factoring of difference of squares. If it's subtraction, obviously, difference. That's going to be the best and easiest way to solve, usually. So what does that mean? We have a formula for it. So when you have the difference of two squares, it means you can write it as a plus b and a minus b. You can factor it like that. We are factoring. Going from here to here is called factoring. And it's sort of just a standard, well-known formula when you have the difference of two squares. So let's try it. Step 1 is to write it as something squared minus something squared. So we know we have put 5 here. Then, if you want to, you could sort of label this is your A and this is your B. Whatever's on the inside there. We'll just kind of plug it in. So it's going to be x plus 5 and x minus 5. And you're done. You factored. You can always check your work. And remember, to do that, all we're going to do is multiply it out. We're going to distribute. So x times x plus x times negative 5. And then 5 times x and 5 times negative 5. Now we simplify. So x times x is x squared. Ooh, look what happens here. This is a negative 5x and a positive 5x. What happens to the middle terms? They go away. And look, we get back to where we started. X squared minus 25. So sure enough, it worked. We factored this binomial and got the product of two binomials. And you're going to see this pattern where the middle term disappears. And that's kind of the whole point of why the factoring of difference of squares works. So let's try some more. Step 1 is to make sure you can write it as something squared minus something squared. If you can't write it like this, you cannot use the difference of squares formula, a minus b. You can also write it as a minus b, a plus b. That doesn't really matter because we're doing multiplication here. So you can think of this as one whole thing being multiplied by another whole thing. So the order will not matter. So this is our a, that entire thing that's on the inside, 4y, and this is our b. So we're going to have 4y plus 3 and 4y minus 3. That's it. Did this on purpose. I want to show you guys something. Let's check our work. We're going to do 4y times 4y, and that gives us 16y squared. 4y times negative 3, that's negative 12y. 3 times 4y, that's positive 12y. And 3 times negative 3. So again, that middle term will cancel. Boom, boom. But look, we have a 16 here. What happened? They do not match. Can you guys see what I did wrong? On purpose. Look, there's a 4 here. Remember, we need to write it as something squared to match this. So 4 is 2 squared. So, that's a very common mistake. So be careful as you're filling this out that you're writing it as that number squared. So when we go to plug it in, it's going to be 2y plus 3 times 2y minus 3. So just be really careful. Make sure you're writing it as something squared minus something squared. There we go. So here's our A and here's our B. So we're going to have D plus 6 times D minus 6. Let me get another color. Okay, the last one here, 5y squared minus x squared. So if you were to just look at this, it might be hard to figure out how to factor that without knowing this special case formula, I think. So that's going to be A and that's going to be B. So we'll have 5y plus x and 5y minus x. And you're done. We factored it. We took this expanded form out and we condensed it. We factored it. I know I keep saying factored, but I just want to make sure everybody understands what does it mean to actually factor something. And it really means we're simplifying it. Next week-ish, we're going to take it to the very next step where we solve for the variable. So you'll see kind of everything coming together. Here's 2 more. We're going to write it as something squared minus something squared. So 2c squared minus 7 squared. This is your A and this is your B. So we'll plug it into that formula. A plus B, A minus B. You don't really need those parentheses. I just like the parentheses when you have something like this because it helps you really isolate what the A value is, you know? So it'll be 2c plus 7 and 2c minus 7. You can always check your work. Last one is, oh, that's so funny. Look, it like rewrote the problem down there. Huh. We have a squared minus 5b squared. So this is our a, and this whole thing is our b. So a plus 5b times a minus 5b. That's it. And that's it for our play pause it. 19 minutes, well, 20 minutes. I hope that you guys have a really great rest of your week. Tomorrow is our virtual outing day, so you won't see any sort of extra assignments. You'll have your Class Connect attendance quiz if all goes well. And I'll still keep our Free Talk Friday sessions on the calendar if you guys want to come. And we have at 11 o'clock a virtual talent show. So even if you're not in the talent show, you guys should totally check it out. Come and see your classmates, your grade level mates, and see a lot of the amazing things that they're going to show us. So that's 11 o'clock in New Row. So we're kind of trying to move away from the Zoom virtual outings because, you guys are used to having your live classes in New Row. So, and seeing them on that schedule part. So you'll see that on your schedule tomorrow at 11. Bye, everybody. Have a great weekend.